In this video tutorial, we shall see the programming of 16 cross 2 LCD using a 8051 microcontroller. So in order to make the programming of the LCD simpler, we shall divide the program into functions, right? Before that, the first thing what you should know is the interfacing of 16 cross 2 LCD with 8051. So this is the first thing you should know. Second is, for programming, we shall divide the program into several functions, right? So in that, let's say the first one is LCD init, right? Wherein we shall initialize the LCD. Then I need a function to send LCD command. Then I need a function to send LCD data, right? And if there are more than one characters, it means if I want to transmit a string, then I need to have a function called as LCD write. So whenever we write some data or some command, so the LCD needs some time. So I need to have a delay function also. That's it. So my program will contain these 5 functionalities, right? And apart from that, the only thing you should know is what are the LCD commands which are supported, right? So first of all, we have 0 cross 3 8, which means we are working on a 16 cross 2 LCD. Then to clear the display, we have 0 1, so this clears the display. Then we have 0 into 80, okay? This is to display on first line. Then we have 0 into C0 to display on second line. And yes, before this we have 0 into 0C. This means display on and cursor off. And to print something on the second line, first you have to activate that line. So for that, the command is 0 into 3C. This will activate the second line. So these basic commands would be sufficient. Apart from that, what else we are supposed to know is, if you want to send a command, LCD command, then for that your RS pin should be equal to 0. And if you want to send a data, LCD data, in that case RS should be equal to 1. And if you want to perform write operation, for that your read write signal should also be equal to 0, right? So these things they provide a general overview of writing a program, right? So with these things on your hand, you can start programming. The program looks lengthier, but the programming is very simple. Okay, I shall write the program for you and you can practice the same. Now let's begin with. So for writing the program, this is the interfacing diagram I'm considering. wherein my data pins of the LCD, they are connected to port 2, and the register select RS pin is connected to 3.5, read write is connected to 3.6, and enable is connected to 3.7. So based on this hardware connection, I shall configure my code based on this hardware, right? So let's start coding now. So hash include register 52.h, right? Now, based on my hardware, I will write the code. So I have a RS pin, so S bit RS equal to P3.5. So this is how we write in C using this XOR symbol. Okay, so this is for register select, right? Then S bit read write, and the pin number is P3.6. Okay, so this is to read or write. Then to enable, we have pin P3.7. So these software instructions are based upon the hardware connections we do, right? And we can also give a name to the port. So I can say that hash define LCD port P2. If you want, you can give, or you can also use P2 directly in the code, right? Now after this, we have seen this that we need 5 functions. So we shall have declarations of these functions. One is void LCD init, right? With no arguments. When there are no arguments, you can write as void. Then I have LCD command, void LCD command. So the commands, whatever we send, they will be of the data type character. So this will be also a character type, unsigned character value. Similarly, the data will also be of character type. And if I want to transmit a string, then I need to have this function void LCD write unsigned character. I will declare this as a pointer. Okay, then I need a function to generate a delay. This will be unsigned int type because the count will be more than 255 here. Or you can unsigned int, let's say some type or value. Fine. So we have declared all the 5 functions now. Okay, so my program will have these functions. Next, I shall write my main program. So one important tip for you here is, whenever you open the parenthesis, you close the parenthesis, then you start programming. For example, now as soon as I open the flower bracket, I'm closing the flower bracket. Okay, so thereby you can reduce most of your syntax errors, right? So this is my main function. Then I will have one more function called LCD init. We shall see one by one. Let me make the structure of my entire program. Then I will have void LCD. You can copy this. The only thing is, you have to be careful is, when you copy, you should remove this semicolon for function definition. So this is the function definition which tells you what this function is intended to do, and this is the declaration. So the declaration which comes before main, that ends with a semicolon, whereas the definition does not. Then we have LCD data function. I will also copy the same. I will remove the semicolon as said. Then I have the other two functions. I will also copy the same. Then here also fine. So the structure of my program is ready, right? Now let's say the first thing in any programming is that we initialize the IO device. So first function to be called is LCD init, right? Now let us say what all we have to initialize now. So we have to send these commands now. First of all, we are working on a 16 cross to LCD. So the command will be LCD. So this is a command, right? This is not a data. Data is something which is displayed on the LCD, right? So what we are sending is a command. So I will call the function LCD command. And what is the command? 0 into 38. And every C statement should end with a semicolon. Okay. So this is 16 cross to LCD. Then as I said, whenever we send some command or data, it should we should give some time. Okay, there are two ways. One is to check the busy flag. The other is to give a predefined delay. So here I am giving some delay, maybe approximately some 1 millisecond, right? So I have sent the first command. The next command is to clear the LCD, because already whatever was written previous, that the same thing will get displayed. So for that I have cleared the LCD. For that command is 0 into 01. Then the next command is to make the display on and the cursor off. For that the command is 0 into 0C. So this is display on and cursor off, right? I will give some delay. Fine. So let's see, these are enough. It depends upon whether you want to print on the second line or not. If you're planning to print, you can say LCD command. So you have to activate the second line. So this will activate the second line. So in future, if you want, you can print on the second line, right? That's it. Now after this, we have to write the functions for command and data. Almost all the instructions will be same, except that in case of command, rs is equal to 0, and in data, rs is equal to 1. Okay. So whatever the command or data we send, that will be received here, and this we have to send to the port to which the data pins are connected. And our LCD is connected to P2, and we have used the name LCD underscore port, right? So whatever the command which is been sent, I am sending this to LCD port, so that is equal to value. If you don't want to give a name to the port, you can also directly use P2 here. Okay, it's one and the same. Then I need to tell the LCD that whatever is available on the data pins is a command. So for that, the function we have to make rs equal to 0, telling that this is a command, right? And here I am writing to the LCD. So read write should also be equal to 0. So 0 means it's a write operation, right? Then once this is done, I have to make enable 1 and enable 0. So what this will strobe the data on the LCD pins. That's it. Whatever the command you have sent, send it to the LCD data pins. Make RS0. This is the write operation, and you strobe the enable pin. And how about the data? The same thing. Whatever the data you receive, send it to the data. And to tell that this is the data, now you make rs is equal to 1. That's it. The other things remain same, right? So we have two more functions to be written. This function is very important. Maybe in this function you may do a lot of mistakes. So what does this function do is, this transmits a string, right? So for that, what we do is we transmit unless we get a null character. Whenever you declare a string, right, automatically a null character is appended at the last. So a null character is nothing but a 0, right? So what we are doing is, unless all the characters are not printed, this function will be called repeatedly, right? And once you receive the null character, it automatically stops. Okay, so here I will be transmitting character by character. Okay, and to transmit a character, I have the function data. So what I do is, I will call this LCD data, and here I will transmit that character. And after transmitting the first character, I have to transmit the next character. So I will say plus plus. Okay, I shall show a pictorial representation of this so that you can understand better. Let us first complete the program, then I shall show you. Then I need a delay. So I have used the same delay which I have used for other programs. So for I equal to 0, I less than whatever the value I receive, I plus plus, right? And for j equal to 0, j less than 1275, j plus plus. The most important thing here is you have to end with a semicolon. And as per the textbook Mazidi, he says that this actually gives a delay of 1 milliseconds. Okay, maybe, right? So all my functions are ready now. The only thing is, now I have to select a proper line and I have to transmit the data. Okay, suppose if I want to select print something on the first line, I have to select that line. So I will send the command. The command is 0 into 80. Okay, and I will give some delay. Fine. Now I can print anything on the first line. Okay, so for that printing, I have the function LCD write. So I will say LCD write. Let's say I want to transmit the message VVCE. Fine, and I will give some delay of 1. And at last, I will end the program with a forever. Okay. Now, once I declare this string VVCE, okay, how is this stored in the memory? Okay, if you say this is your memory, right? So what happens is, here this is some address. Okay, this is the address, and here is where your data is stored. So ASCII of V, then here also V C E, and automatically this will be terminated with a null character. So this is the null character, right? Now what happens is, when we call LCD write, so you are actually calling this using the pointers, right? Now star string means it will extract the contents from that memory address, right? So first it will take V. So V is a non-zero character, so this function will be called, that is LCD data, and V will be printed. And when I do star string plus plus, okay, now that will point to the next data, that is the next character, right? And this will continue unless it finds a null character. So a null character is nothing but 0, right? So when it comes here, it finds that to be 0. and this condition fails. So this program, this function will work unless it finds a null character. Okay, and the C program itself appends whenever you declare a string, automatically a null character is appended. So we need not worry about this, right? So this is how this program works. Okay, so quickly we shall compile this. So that's good. We don't have any errors and warnings, right? So I shall dump the code for you just to make sure that this is my hex file. I will compile again. Yes, this is the hex file. Now let's see that whether the message will be printed properly or not. Yes, so we have written a correct program, right? Now if I want to print something on the second line, I've already activated the second line, right? So what I have to do is I have to now send the command for printing in the second line, and the command is 0 into C0, and whatever the data we want to print, let us print. Let's say I want to print now Department of EC&E, right? I will compile this and I will enter this. Fine. Now let's say I want to print VVC from this 5th position. Okay, so for that what we have to do is, so when we send the command 80, so 0 stands for first position, right? And if I write 1, that is the second cursor position of the LCD. Now that I am planning to write in the 5th position, so I will make this 4. So this continues 5, 6, 7, 8 until that 16 characters. Okay, so let me compile. You will see the difference. Now see. So that's it. So this is how we program the LCD, right? So if you have these data handy, you can easily write the LCD program. Okay, so that's all about the LCD programming.